Welcome to the Capital Light Assembly podcast brought to you by Edison Manufacturing and Engineering. Edison is your contract manufacturing partner focused on capital-efficient assembly of complex mobility and mobility-adjacent products that are not well-suited for highly automated production. I'm Brandon Bartnick, Vice President and General Manager here at Edison, and you're listening to part of a special series here focused on how to reliably scale production of autonomous vehicles. So how can you execute and scale that production building autonomous vehicles? This is part of our core business, an area where we have a lot of experience and expertise. We're using this series as a way to share some of that knowledge for anyone who's going through this process. So hope you enjoy it. There's 7 total tips, 7 episodes here. So check out the ones before and after this. And please enjoy. The next tip is to realize that this will be a human-heavy production process for a while. So plan accordingly, right? And it's a mouthful, but think about that. So the process for autonomous vehicle builds, especially if it's in an upfit or retrofit application, you're getting a vehicle that has not designed for autonomy. I mean, maybe it has a by-wire system integrated into it, and that's something that'll be more common as we go forward, but not going to have the sensors, the harnesses, or the compute that you need installed and whatever else comes with that, right? So what was required is tear down and some subassembly build, and then installation of those subassemblies, often in tight corners, and some stuff like interior tear down and reinstallation and running wire harnesses and stuff like that. Most of which is difficult to automate and will be expensive to automate, and especially if you pair that with the idea of trying to be capital efficient, like it makes sense to use a human-led process here for a while. So the dichotomy, though, is if you think about the previous tip of how important quality is here and how important it is that things are done correctly and repeatably. Introducing humans into that system is a challenge at times, right? Because we are more prone to make mistakes than robots and automation generally are. So how do you do this? And again, it starts with effective quality planning and quality management system, like the APQP process, and you'll use your design failure modes and effects analysis, process failure modes and effects analysis to define the controls that you need and identify the quality critical items and things that need to be addressed. But assuming you do all that well, how do you then have a human-led process that is reliably and repeatedly executed? And one of the important tools that are at your disposal here is operator work instructions. So what information is the operator processing when they're building? And it's important that they're getting exactly the information that they need at the time and place they need it. And they can see what they need to do, how they need to do that, and possibly most effective, importantly, why they need to do it in a certain way. And you often pair that with, what are the things to look out for, and where are there errors that can be made. And that sounds simple, but it's not something that is often done well. So thinking about how can you get that information in a way that the operator is actually going to use and benefit from it. And again, the information that they need, when and where they need it, every time. And so operator work instruction, design, and execution is very important. And then building out, you pair that with some foundational stuff of like the people who are actually doing this. It's important that you have the right people. So operator selection and the way in which you are recruiting and hiring and training the right people to be doing this work is very important. The way in which you're designing the process is important. Introducing Poka-yokes and assuring that whenever possible, you can't build this thing the wrong way. It's just kind of blocking and tackling in the manufacturing world, but you have to do it well if you're going to effectively build autonomous vehicles at scale. And then last one, again, this is a fundamental thing, but good operations management is critical here, and giving the support and leadership and direction and oversight that's required to have a high performing team who's going to do this. So several of these, so like the operator work instructions is maybe the biggest thing that doesn't seem obvious. The rest of it's kind of like, if you're coming from a manufacturing world, yeah, it makes sense. Design a good process, operate that process well, and have good people to work in, but just because it's simple doesn't mean it's easy. So these you have to get these fundamentals right when you're playing with when you're working with something that's so safety critical. So yeah, this tip, realize that this will be a human heavy process for quite a while. Plan accordingly.